Hi, folks. Let me continue where we left. Not that number 9, number 10, or number 11 is not any important with this, but for the sake of discussion, I assigned number 8, 12, and 18 as part of your homework with it. Take a look at number 12. Number 12 in your book on page 108 basically says want you to write some C++ statement that accomplish some of these statements in here. So what I'd like to do is let me move this down here and kind of make this kind of, can you see that in the behind screen, and we use this as up here with it. So this is number 12, page, what is this, 108, and I'm going to start you out with this, and you can finish the rest of this probably with it. But anytime when they ask you to declare something, you got to start out with something with the data type, right? They tell you the data type is an int. So you can always start with an int, and they want you to do variable x and y, initialize it to 25 and 18 with this thing. So if you did this, all right, so the syntax is the data type space, the identifier is what? It's x or y, right? Let me just bump this down here so we have separate that from that a with it. So in here, that's what you have is the data type is an int, and you have an x and y with it. So there's two ways to actually do this. You could do this way, or you could do it this, like that with a y. Both of these, or the other statement is just to simplify this, as you can do x, y. This will work as well, separate with a comma with it. However, when they want you to initialize something with it, you could do, in this case, equal to 25. This will work, or int y equal to 18. This will work. Okay, so either way, one of these will work. Now, what will not, somebody's going to ask me is, can I do this? Of course, somebody, can you do something like this, equal to 18? Okay, this is a no-no. You can't do this. Okay, the compiler's going to choke, and it's going to, well, that's bad programming with it as well. So either you declare, you can initialize and declare at the same time one statement, and set this thing as 18 with it. See, and semicolon. It's like a sentence, an English sentence. You have subject, verb, and a punctuation. Three things. You have data type, space, identifier equal to your whatever value that you initialize with. So that's basically, that's starting you out with this B. It asks you, the next statement is to basically declare, initialize a variable int to a temp10 and a char to a ch. Well, same thing, right? So I'd like for you to do that on your own with it. So this I'm not going to they tell you the data type. Here's the data type, it's a char to ch. So you do that over here, and you tell me how do you declare a temp with a int database. I set it equal to 10. Same thing, right? I'm not going to give away the answer with that. So it's very similar to A with it. Letter C, okay, update the value of x, a data type of x, by adding 5 to it. Very interesting with this. So C gives you a little bit more of an update. Remember now, when we talked about something that is an equal sign, I repeated this over and over, the right side equals the left side. Remember that? So in this case, they want you to update the value of an integer variable x by adding 5 to it. Simple enough. Alright, so let me do this. So if I want to x add 5, okay, now I want to update that. Update what? Update this x, right? Remember now, update the value of an int variable x by adding 5 to it. It's actually the same variable every time when you assign equal to it, equal to the left hand side, that's your x. Okay, so again, this is, you're updating x, add to 5, now it's assigning to the memory. So what do I mean then by that? So let's say you start out with x. This is not part of the problem, by the way. Let's say you start out with x, int x is equal to 0. Okay, what do? You put this x right here. What's that? 0. X becomes 0 here. 0 add to 5 becomes your new x. Now in the memory, x no longer becomes 0, but it becomes 5. You with me? So that's what that statement means with it. Okay, so just to give you a little clear understanding what I did with it. Okay. Now, I'm not going to go through this entire problem with you, but do your best, and if you could, I don't think you're going to have any trouble with D. Declare, initialize, pretty much the same way. Declare something, here's how you declare it, and you initialize it. You assign this value to this identifier pay rate. Look at E, same thing. Copy the value of an int variable, right? So what is that? You're copying first into temp num. So what the question that I would like to pose in 12E is, what side of the equal sign does first num belong to? If you're setting this to equal your temp num, okay, remember what I said, the right side equals the left side. In F, you also have, it says swap the content, and this is a really nice, let me help you with this one. This is a little tricky. I'd be careful with this. It says swap the content of the int variable x and y. Swap meaning you switch it, right? So that's, I'm just highlight this. Okay, just grab this and paste in here because I'll be working, or maybe move this up a little bit. I can actually see both of these things. So in F, let's take this off. In F, you have it says swap. Well, remember what I just said. You have to let the right side equals the left side. Right now, in F, it says there's the int variable x and y. Okay, that's what you have. Declare an additional variable if necessary. So I just declare x and y for now with it. In here, here's what I'd like for you to think about. The memory of x needs to be stored as in the swap variable. I'm just going to call something, another one's going to call, let's call this one temp. It's a temporary place with it. How's that? So here's the algorithm with this thing is, you're going to let, I want to write this from the right side equals the left side. Okay, so equals x, that's going to be stored in the temp, and then I want to set y to equal to x. So I'm going to set y equal to x. So this x right here is this x right here. So, and then I'm going to assign this y right here is going to overwrite that x right there. You see what I'm talking about? So you're going to come down here, I'm going to use this y right here. I'm going to write y temp is going to equal to y. So let me just clarify what I just did. I declared all these variables, 3 variables in this, and I'm going to use the x to store that in the temp. I want to take this x right here, that is this memory right here. I want to take this y, wipe out what's inside the x. Okay, it's kind of, that's why they call it the swap, S-W-A-P. And then I want to take this temp up here and put into the x. So basically what actually happens, let me pause this a second. So let me just depict some memory, some changes here for you to see. I'm going to draw just a kind of like a little graphic box of what's a variable inside of this. I have x, I have y, and I have temp, short for temporary. So I'm going to take the temp, we're going to use some numbers here, okay? So let's say my x right now that I have is 3, okay, 4, and 1. So I like to swap the 4 and the 3 in the x and y, right? Actually, this is nothing in here, actually. Okay, so I'm going to take 3, store that in temp, take this 3, put that in temp. So if I was doing this as a memory, that's what I call is that trace table. 3 goes into temp is here. See that? And then I'm going to take the y, which inside y right now, assign it to x. So inside my y, I want to put in my x is 4. I want to take my temp, which is here, which is 3 here, right? This 3 now is going to go here. Okay, so what I've done is I swap the x and the y. Okay.